5, inequalities in triangles. Reminder, today, 5.5 worksheet. Tomorrow, chapter review. Thursday, quiz, whatever you want to call it. Okay, the small quiz. It's worth 50 points on on Thursday. Okay, instead of the usual 100.
So can we correct it or not?
Yeah, I don't know. We'll have to wait and see. I haven't thought that far. Inequalities, those are the less than and greater than symbols. That's what we're working with. We're trying to decide if an angle is less than another angle, or if a side is greater than another side, and all that for triangles. I'm going to skip then the comparison property at the top, and I'm going to jump to the corollary to the triangle exterior angle theorem. If you remember, back in chapter 3, the triangle exterior angle theorem states that the measure of an exterior angle of a triangle is equal to the sum of its remote interior angles. So angle 1 would equal the sum of 2 and 3 added together. That's the exterior angle theorem. A corollary is something that branches off of it that you can get afterwards. And the corollary states that the measure of angle 1 has to be greater than the measure of each of its interior angles. That angle 1 has to be greater than angle 3, and the measure of angle 1 has to be greater than the measure of angle 2. Hopefully you are thinking that's pretty logical. If 2 plus 3 equals 1, wouldn't both of these have to be smaller than 1? Because you're adding them together to get to 1, right? Okay. A lot of times you can kind of go based off looks too. I mean, most of the time there's an obtuse angle, so that's going to be greater than your acute ones, but not always. So an exterior angle greater than the 2 interior angles. The next two theorems, 510 and 511, I'm going to just tell you what they, mean together instead of reading them individually. So on your note packet, you can either write that in this margin by theorem 10, theorem 511, or you can write it in this margin. Okay. But together, they say that the longest side of a triangle is opposite the biggest angle. The longest side of a triangle is opposite of the biggest side. All right, there. And then the shortest side of a triangle is opposite the smallest angle. The longest side of a triangle is opposite the biggest angle, and the shortest side of a triangle is opposite the smallest angle. Opposite means across from, not touching that angle. This is what theorem 510 and 511 are saying in the fewest amount of words. Here's triangle ABC. We'll say this angle is 30. This one is 42. 72. So this angle's got to be 108, right? Is that right? Did I do my math right? Does that add up to 180? Okay. So it doesn't go by looks here. You got to go by the measurements. Since angle A is my smallest angle, which side should be the shortest one? CB. The smallest angle is always across from the smallest side. So I would know that CB is my smallest side or shortest side. Okay. B is 108, my biggest angle. So which one's going to be my longest side? AC. Biggest angle is opposite of the longest side. Smallest angle is opposite of the shortest side. Again, I didn't draw it to scale, but that's what those two theorems say. And then obviously the one in the middle goes with the side that's in the middle between the other two. Okay? Cool. The last theorem, theorem 512. I don't like this yellow color very much. The triangle inequality theorem says the sum of the lengths of any two sides of a triangle is greater than the length of the third side. What does the word sum mean? Addition. So if I take any two sides and add them together, that value needs to be greater than the third side, the side that I did not include. Okay, here I have a triangle with lengths 3, 4, and 5. If I use these equations, these inequalities that I have written here, LM plus MN, 3 plus 5 gives me what? Is that greater than my third side? Yeah, so then that would be, we'd say it's a triangle. Add the other two sides, MN and LN. So 4 plus 5 gives me 9. Is that greater than the third side? Sure it is. If I add the last two, LN plus LM, what's 4 plus 3? Is that greater than 5? Yeah. So these three sides, like if I gave you pieces of string that were 3 inches, 4 inches, and 5 inches, you would be able to take the pieces of strings at their endpoints and match them up so that they make a triangle. Okay. Let's pretend that MN is the length of 8. Then when I add 3 plus 4 and still get 7, is 7 greater than 8? No, so if I gave you pieces of string that were 3 inches, 4 inches, and 8 inches, you wouldn't make a triangle. What would end up happening is that this one would hang out just a little bit too far. I wouldn't be able to stretch this 4-inch piece of string all the way to that end point. Okay, so really, the smallest two sides, when you add them together, have to be greater than the third side. So when you check, you always are going to add your smallest two sides. We'll practice. If I say the side lengths of a triangle are 8, 17, and 32, we'd have to decide if this would really work. Pick the smallest two sides. What are my smallest two sides? What's the sum of 8 and 17? Is that bigger than 32? No, so then that means I can't create a triangle with pieces of strings that are 8, 17, and 32 inches. That 32 is going to be way too big. I'm going to have stuff hanging out. Okay? Cool. Here we go. Example number 1. Is the measure of angle 4 greater than the measure of angle 5? And you need to explain. So take a minute to observe your diagram there, and if you think you got it figured out, raise your hand and let me know. Rain, you got it already? Okay, give me your explanation. Okay. Okay. Okay, so he said that angle 5 is congruent to angle 2 because they're corresponding angles. You guys agree with him? Since I have parallel lines, my corresponding angles have to be congruent. Okay, then what'd you say now, Rain? Okay. So I could say that the measure of angle 2 plus the measure of angle 3 equals the measure of angle 4, and that would be that triangle exterior angle theorem. Okay, then tell me how we say that 4 is greater than 5 from that. The measure of 5 plus the measure of 3 would also add up to the measure of angle 4 by substitution. Okay. How does that tell me that 4 is greater than 5? Say logic, Mrs. Carroll. Yeah, it's the thing I skipped at the top, the comparison property of inequality. If you're going to add two things and get a third, this third one has to be greater than one of those two. So we could say that the measure of 4 is greater than the measure of 5 by our comparison inequality property. That works for me. It's like a little sketch of a proof because I got my steps on the left side, my reasons on the right in parentheses. RG is 14, GY is 12, and RY is 20. I think I labeled your triangle already for you. You need to list the angles from largest to smallest. on your homework today and your quiz thing on Thursday, these should hopefully be the easy points, but this is probably where most students make mistakes. Why do you think students are going to make mistakes here? What do you mean by that, Franson? Good, they won't read it very carefully. It'll say put your angles from largest to smallest, and they'll put them the other way. So make sure you read carefully. This is using theorem 510 and 511 smashed together, what I had you write in the margin, which you guys should have wrote the biggest angle is opposite the longest side or something like that. And then the smallest angle is always across from the shortest side. So I'm listing the angles from largest to smallest. I need to find the biggest angle first. So which side length should I look for, the longest one or the smallest one? Longest one, which is 20. Which angle is across from it? G. So angle G is my largest angle. I like to cross them off so I don't reuse them. Then I got to go to the next largest side, which is what? GR 14, and the angle across from it? Y, which means my smallest angle is R, because it's across from the smallest side. Biggest angle across from the biggest side. Smallest angle across from the smallest side. Cool. Flip it. What, Kilgore? Kilgore, if you weren't sleeping in class, you'd know that answer. I've said it for the last 2 weeks. Okay, we'll have to check my lesson plans next time. Or just wait and find out. Number 3. Can a triangle have side lengths with the given lengths? So if I give you 3 pieces of string and one's 2 centimeters and one's 2 centimeters and the third one is 4 centimeters, would we be able to connect those pieces of strings right at their endpoints and make a complete triangle? You said no. Good. When you do this, add the smallest 2 sides. So what are the smallest 2 sides here? What's 2 plus 2? This number has to be greater than the third side, is it? No, it's equal to it. It's not the same. Being equal and bigger, those are different things. So this would not be a triangle. That sum of the smallest 2 sides has to be greater than the third side. So B, I'm giving you an 8-inch, a 15-inch, and a 12-inch piece of string. Okay, so I need to add my smallest 2 sides. What are they? Good, 8 and 12. What's 8 plus 12? Is that greater than that third side? Sure, so then yes, this would make a triangle. Those pieces of strings would line up at the ends and I wouldn't have any extra stuff hanging. Sarah. If it doesn't say explain, then you can just write yes or no. Sometimes it'll say explain afterwards, so you can just show the work that I showed. That would be your explanation for me. Okay. Okay, number 4. In triangle FGH, FG is 9, GH is 17. We're trying to figure out what the third side of the triangle could be, the length of it. Think about what we just did on number 3. How were we able to decide if they're triangles or not? Franson? So X needs to be bigger than those two? Yeah. So you're telling me that 9 plus 17 has to be less than X? If X, okay, let's play it that way. If X is the biggest side, then these two would be my smallest 2, right? And those 2 added together would have to be bigger than X or smaller than X? Well, let's just pretend that it is the longest side. Then 9 and 17, when you add them together, would they have to be bigger or smaller than X? Bigger, right? The smallest 2 sides would have to be greater than X. So what's 9 plus 17? 26. So this is saying 26 is greater than X. Or if you read it backwards, x is less than 26. So if 26 is the longest side of the triangle, it has to be anything less than 26. X is the biggest side. Let's pretend that x is 30. Then when I add my smallest two sides, what's 9 plus 17? Is 26 greater than 30? So it can't be 30. It can't even be 26 because then they're equal to each other. Yeah, if it's 25.5, it would work because my smallest two sides, 9 plus 17 is 26, which is greater than that. Rashid, what were you saying though? It could be one of the smaller sides too, right? If x is one of the smaller sides, then which ones of these are the longest one? 17. So if x is one of the smaller ones, wouldn't we have to say that x plus 9 has to be greater than 17? Okay, subtract 9 over, what's 17 minus 9? 8. So this sentence reads x is greater than 8. So if 17 is the longest side, then x has to be anything bigger than 8. If x is 9, what's 9 plus 9? Would that work? Okay. If x is 4, what's 9 plus 4? 13. Does that work? No. So the possible lengths of FH, x can be anywhere between 8 and 26. It can be any value between those two, so that we fulfill the theorem that the smallest two sides, when you add them together, have to be greater than the third side. I think it is. Okay. Number 5. If CY is congruent to XY, explain why the measure of angle 4 is greater than the measure of angle 1. Because I somehow got to get angle 1 down there. Did you hear him? So since these two sides are congruent, which two angles have to be equal? Good, 1 and 3. And therefore, since 4 is greater than 3, and 3 is congruent to 1, we can say that the measure of 4 is greater than the measure of angle 1. Here is your reasoning to this. I'm going to put it on the other side. This is the corollary to triangle exterior angle theorem. It's the one at the front, first one. Angle 1 is congruent to angle 3 because if two sides of a triangle are congruent, and the angles opposite of them are congruent, that's the isosceles triangle theorem. And then we used substitution at the end. Number 6, list the angles in order from smallest to largest. List the angles in order from smallest to largest. At least when you're sleeping, you're not blurting things out. Angle. A, because it's crossed from the smallest side. Which one is the next smallest angle? And then B. Good. ACB. All right, number 7. Can a triangle have sides with the given lengths? Explain. Again, when you explain, if you show your work, that's your explanation. Otherwise, you have to write it in a sentence. Emily, what did you get for 7A? Would those lengths make a triangle? Why not? Good, and 9 is definitely not greater than itself, right? Quigley, what about B? Do these 4, 6, and 9 make a triangle? Why? And 10 is? Good. Again, explanation, if you show that work, that's your explanation. Otherwise, you'd have to write a sentence. Number 8 is just like number 4. Well, similar to number 4, not just like it. A triangle has possible side lengths of 3 inches and 12 inches. Describe the lengths for the third side. Okay, so if you drew a picture maybe of something like this, 3 inches x and 12 inches, we have to decide, gentlemen, what the range of x values we can have here. I do it 2 ways. First, I think if x is the biggest side, if this is the biggest side, then the smaller two, 3 plus 12, have to be greater than that side. Smallest two sides have to be greater than, what's 3 plus 12? 15. So 15 has to be greater than x. Read it backwards, and it says that x has to be less than 15, so it can be no value bigger than 15. That's if it's the longest side. If x is one of the smaller ones, then which one is my bigger one? Biggest one. Thanks. If x is the smaller one, then that means 12 would be the biggest one. So 3 plus x would have to be greater than 12. How do you move 3 over? That means x would have to be greater than what? 9. So then your x values would range from 9 to 15. It can be anything in between it, but nothing on the outside. Can't be 15, right? Sorry, I didn't mean to. All right, Veronica, if I'm looking for the biggest angle, should I look for the biggest side or the smallest side? Good, biggest one. So 5, 8, and 7, 8, YZ. This would be my longest side. So then which angle is my biggest angle? Good, angle X. It's the one that's across from it. Number 10, triangle PQT. We know that P is 50, T is 70. What's 70 plus 50? 120. What's 180 minus 120? 60. Okay, you may want to check your third angle if they don't give it to you. In this case, it doesn't really matter because the shortest side should be across from which angle? The smallest one. What's my smallest angle? P, which is across from which side? Yeah, QT or TQ.